In this video lesson, we're going to learn about oxidation and reduction reactions. So a little bit about redox reactions. Redox reactions, also known as oxidation-reduction reactions, have to occur together. So if something is being oxidized, something else has to be reduced. And it can involve the transfer of oxygen, hydrogen, and electrons. So some examples of redox reactions in everyday life would be corrosion, photosynthesis, and cellular respiration are redox reactions, as you would remember from learning that in biology, and also combustion reactions are redox reactions. So redox reactions can involve the transfer of oxygen, and that's the original definition for redox reactions is oxidation is a gain of oxygen and reduction is a loss of oxygen. So that's where oxidation and reduction is coming from. So in this example, copper 2 oxide is being reduced to copper, so it's losing oxygen, and then hydrogen is being oxidized, gaining oxygen to become water. So that would be an example of a redox reaction that involves the transfer of oxygen. We also take a look at the transfer of hydrogen, and this is what we paid more attention to in biology, and in organic chemistry we will as well. So in organic chemistry, redox reactions normally involve the transfer of hydrogen. So in this instance, oxidation means a loss of hydrogen. So hydrogen sulfide loses hydrogen to become sulfur, and then reduction is a gain of hydrogen. So chlorine gains hydrogen to become hydrogen chloride or hydrochloric acid. Redox reactions also involve the transfer of electrons. So in the example that we see here, oxidation is the loss of electrons. So zinc is losing electrons to become a zinc ion in solution. And reduction is the gain of electrons. So copper 2 ions gain electrons to become copper solid. It's a lot harder to trace the movement of electrons, however, so we often look at the movement of oxygen and hydrogen instead. So to do a recap, oxidation is the loss of electrons by an atom or ion. Reduction is the gain of electrons by an atom or ion. And a little way to remember that is Leo the lion says grr. So loss of electrons is oxidation for Leo, and then gain of electrons is reduction for grr. So sometimes you'll be asked to explain or identify the oxidizing or reducing agent. So the oxidizing agent is the substance that causes oxidation, and it gains electrons and is therefore reduced. So remember, if something is being oxidized, something else is being reduced. So the oxidizing agent is the thing that's being reduced and it's causing the oxidation of the other thing. And then the reducing agent is the substance that's causing reduction. So it's losing electrons and becoming oxidized. So if we take a look here, this reducing agent is losing electrons. So it's being oxidized. And then the oxidizing agent is gaining electrons and it becomes reduced. So B is reduced and A is oxidized. So redox reactions consist of two half reactions, the oxidation half reaction and the reduction half reaction. So if we took a look at this reaction here, we have copper reacting with silver ions to make copper ions and silver. So what's happening is the copper is losing 2 electrons, so it's the oxidation because it's becoming a positive ion. So copper becomes copper 2 plus and 2 electrons, and then the reduction is the 2 silver ions are gaining 2 electrons to become 2 silver atoms. So that would be the example of the two half reactions. So sometimes we might be asked to use the oxidation states to find out where things are losing and gaining electrons, and this we'll have to do in more complicated reactions. So oxidation will cause an increase in the oxidation state, and reduction causes a decrease in the oxidation state. So in this example, we have zinc is becoming oxidized, so it's increasing in its oxidation state, And this copper is being reduced, so it's decreasing its oxidation state. So this is how we find out the oxidation number. So all elements, if they're an atom, have oxidation numbers of 0. So sodium is 0, the chlorine and chlorine molecules is 0. Hydrogen in all compounds has an oxidation number of +1. So the hydrogen in HCl is +1, except for hydrogen in hydrides. So remember, hydrogen can either gain or lose electrons. So a metal hydride, the oxidation number for hydrogen would be -1 because it's acting as the negative ion or the anion, and the metal is acting as the cation. The oxygen in all compounds, except peroxide, we'll get to it, is -2. So in water, it's -2. But in peroxides, so like hydrogen peroxide, it's -1. So that's the one exception to keep note of. Metal ions is whatever the charge is on the ion. So sodium would be +1, magnesium would be +2, and so on. Polyatomic ions is the sum of it is equal to the ion charge. So in hydroxide, oxygen is -2, the hydrogen ion is +1, you add them together and you get a -1 charge. That's the ion charge. So that's how you do those ones. So in our example, we're being asked to determine the oxidation state of the carbon in hydrogen carbonate. So in this example, remember some of the rules. So the oxidation state of hydrogen is +1 in compounds, and the oxidation state of oxygen in compounds is -2, except for in peroxide, but this is in peroxide. And because hydrogen carbonate is a neutral compound, the sum of the oxidation states has to equal 0. So to solve this, it would be 2 times the oxidation state for hydrogen plus the oxidation state for carbon plus 3 times the oxidation state for oxygen is going to equal 0. So we'll plug our numbers in. So 2 times +1 plus carbon plus 3 times -2 equals 0. So we have 2 plus carbon plus, minus, just a second, minus 6 is equal to 0. So we have -4 plus carbon is equal to 0. We'll transfer the -4 to the other side. So the oxidation state of carbon is +4. So that's how you find out the oxidation state. In our next example, we're being asked to find the oxidation state of the nitrogen in the nitrate ion. So we know again that the oxidation state for oxygen is going to be -2. And because it's an ion with a -1 charge, our oxidation states have to be equal to -1. So this time it's going to be N plus, there's 3 oxygens again, 3 times -2 is going to equal -1. So N minus 6 is equal to -1. So we'll have to transfer that to the other side. So add 6 to both sides. So nitrogen's oxidation state is going to be +5 for this example. So with transition elements, it will be a little different. Remember that they can have varying charges, meaning that they have varying oxidation states. So for example, copper 1+ has an oxidation of +1. Copper 2+ has an oxidation state of +2. Now, sometimes we have something known as disproportionation reactions. So in some reactions, the same reactant will form 2 different products. So for instance, in a decomposition reaction. So in this case, one of the reactants will be reduced and the other one will be oxidized. So the example we're going to use is actually the decomposition of hydrogen peroxide. So H2O2, it breaks apart into 2 H2O plus oxygen. And if you take a look, the oxygen in H2O2 is being oxidized to become O2. So it was H2O2 and it's been oxidized. So it went from a -1 oxidation state to 0. because now it's a compound, an element that doesn't have a charge. And then the oxygen in hydrogen peroxide is reduced to become water. So it went from an oxidation state of -1 to -2. So that's how you identify the different oxidation states in these types of reactions. So for some added practice, you can go to section 9.11 and section 9.12 and complete all of the section questions.